Higgs boson mass puzzle. This is the topic of discussion in today's lecture. In 2012, Higgs boson was discovered at Large Hadron Collider. And with this discovery of Higgs boson, it brings a conundrum known as Higgs boson mass puzzle. Yes, it is a puzzle about its mass. If you study particle physics, then there you would find a standard model of particle physics. Actually, this standard model of particle physics is able to explain many things, but not everything. Okay, at Large Hadron Collider, they observed, means they have got experimental value of the mass of Higgs boson to be 125 giga electron volts. Okay, around 125 giga electron volts. But that experimental value of Higgs boson does not match with the predicted value. How the prediction was made? The prediction of the mass of Higgs boson was made using standard model, the theory of standard model. If you want to apply the theory of standard model for the calculation of the mass of Higgs boson, what is the requirement? A requirement is to use the quantum field theory. And to apply quantum field theory principles for the calculation of mass of Higgs boson, you would find that quantum corrections are required. Means I am talking about vacuum is not actually empty. Quantum vacuum, the term is normally used as quantum vacuum. This is not actually empty. This is full of quantum fluctuations. And if you take into account these quantum fluctuations, means actually virtual particles exist in empty space. And we are talking about the fluctuations of all those virtual particles. Okay, so if you take into account the effect of all these virtual particles or the quantum fluctuations for the calculation of the Higgs boson, for the calculation of the mass of the Higgs boson, then you would find that the predicted value becomes much larger, much higher than the experimental value. Actually, what is the result? For the calculation of mass of Higgs boson, high energy scale is involved, such as Planck scale, which is equal to 10 to the power 19 giga electron volt. It is a very large scale. So since high energy scale is involved and these fluctuations are proportional to the energy scale squared, it is square of the energy scale. So automatically, means for this reason, the predicted value of the mass of Higgs boson becomes much larger than the experimental value. But what is the requirement? A requirement is to use such a theory which can accurately predict the value of the Higgs boson, so that the theoretical value and experimental value matches with each other. That is the requirement. So that means fine-tuning of parameters is the requirement. We need to do fine-tuning of the parameters involved in case of Higgs boson. Actually, Higgs boson is what? Higgs boson, this is responsible for the mass of the elementary particles. It is thought that the universe means Higgs field is there and Higgs field permeates the whole universe. And Higgs bosons are nothing but the fluctuations of the Higgs field. And these fundamental particles, means I am talking about Higgs boson, this is the reason for the mass acquired by the elementary particles. So this was all about Higgs boson. What is Higgs boson actually? And mind it was discovered just 12 years back in 2012, and this is 2024. This particle Higgs boson was discovered just 12 years back. Anyway, so the puzzle is what? The predicted value of the mass of Higgs boson is not matching with the experimental value. That means there are discrepancies in our existing theories of physics. And that's why we are not becoming able to predict the correct value of the mass of Higgs boson. Yes, so far physicists have proposed different solutions to solve such a problem, such as supersymmetry. This is one concept. This supersymmetry, or this is also known as SUSY, S-U-S-Y, SUSY. Okay. This is actually an abbreviation used for supersymmetry. Anyway, this thing I will discuss in a separate video, not in this video. So supersymmetry is one such solution to the problem of mass puzzle about Higgs boson. Then again, anthropic principle is there. The concept of extra dimensions. You know that in the string theory, there are not 3 dimensions or 4 dimensions are used. Instead, 11 dimensions are used. 10 dimensions, 11 dimensions, these are used in the study of string theory. That means there is a need for extra dimensions to solve such a problem with Higgs boson. So many proposals are there to solve such a problem. Again, scientists are doing their best to conduct experiment using Large Hadron Collider to explore into this matter. Again, there are future colliders. I am talking about future colliders. At present, those colliders don't exist. Such as name is given like a future circular collider. Means FCC, in short, FCC, future circular collider. Then again, there is a international linear collider, ILC. These are future colliders. Okay, at present these colliders don't exist. At present, the largest machine in the world, or largest collider in the world which exists, is known as Large Hadron Collider. Yes, at present this collider is still being used by the scientists for different purposes, as well as to know each and everything, or to know the known things precisely about Higgs boson. It's very interesting. And you know that this Higgs boson, this is also known as God particle, but many scientists deny to use this term God particle, because the word God is linked, or God is involved in this term God particle. Actually, scientists don't like to use this term God, but many people use this term God particle instead of Higgs boson. Means scientific community is against the use of the term God particle. Anyway, so in my next video I will discuss about supersymmetry, how the concept of supersymmetry can solve the problem of mass puzzle related to what? Related to Higgs boson. Anyway, so this was all about outside noise is coming. Anyway, ignore that sound. Anyway, so this was all about today's lecture. The topic was what? Higgs boson mass puzzle. Higgs boson mass puzzle. Okay. So this was the topic of discussion. So this is the end of this video. Thank you. Thank you for watching this video.